Alright, sorry about that. We are doing page 166, skipping 8. We already did 1 and 2, so this is actually number 3 we're on right now. You can just skip 1 and 2. Number 3. Supposed to add the functions together. Keep going, guys. If you You guys agree with me on A?
Yeah. No. Wait. Oh yeah.
Square plus 2x. B. So on B, you just gotta make sure you subtract both of those.
Yeah,
Minus x, 2x minus x, and minus 2. And fx times g of x squared plus 2x times x plus 2. This would be a FOIL problem first. X cubed outside, 2x squared inside, 2x squared, and last 4x. Middle two terms are like terms. What's 2x squared plus 2x squared? 4x squared, not x to the 4th because that would be multiplying. Whoops, I said not that. I can't talk and write different something else at the same time. Beyond my powers. Alright, and then D.
yeah.
Okay, D looks hard. You might think like long division or synthetic division. If you use synthetic division, it would be 1, 2, and 0 across the top. Did anybody do that?
Yes.
And then it would be what in the box?
-2.
-2. Okay, I'm not going to do that because there's actually an easier way. You got to kind of be looking for it. What is the top factor to? What can we do to factor the top?
X minus 2.
Take out
X and a 2.
Take out an x on the top. Both of those have an x in it. So you factor out an x like that. You guys see where I'm going with this?
Oh yeah.
X plus 2's cancel out. So it's just x. So if you did synthetic, you should have got 0, 1, 0. That's what that tells you.
I got 1, 0, 0. I got 1, 0.
Or yeah, sorry, 1, 0, 0. This is the remainder, not the. Yeah, my bad. 1, 0, 0. So that means no constant term, 1 on the x term, 1x. Even if you use synthetic, this is actually the final answer. You can't just leave it with this. Okay, number 4 is kind of the same family. Do you guys remember what f dot g of x means? F of g of x. And what did we do with that? Okay, I think it's a little more confusing when they put it in that notation, but what it means is, the way I like them to write it is like this, f of g of x. That's how I say it too, but that's what it means. So you take everything that is g, and you drop it into the f function where the x used to be. So f of x was, what was it, x squared plus 2x? And g of x was x plus 2. So we're supposed to be picking this up and putting it into the f function where the x was. So that's what's going to happen there and there. Kind of a lot of work on this one. No, it's not always a lot of work, but this one kind of. So we have x plus 2 squared plus 2 times x plus 2. far so good? Why don't you guys try to simplify that, see how that goes? That O was too big.
I only got plus 2x. So the first equation is x squared plus 4x plus 4. No, so it's just plus 4 because it's not. It's just a 2. It's just x plus 2. So if you square 2, it's just 2. So this would be x squared plus 4. 2 squared is 4x. And it just goes to the bottom.
X plus 2 does need to be FOILed. So it'd be x squared plus 2x plus 2x plus 4.
Did not do that. So it's x squared plus 6x plus 8. Yeah.
That's what I got so far. And we're gonna finish x squared plus nothing, x squared plus 4x plus 2x plus 4 plus 4. Okay, and then the other one goes the other way, g of f of x, and that should be a lot easier actually. So why don't you get 4b to try, g of f of x. So this time we're picking up f of x and putting it into g.
Is there any, you don't even have to give me simplifying, do you?
A little bit. There's an x and the x's go together.
They do. What is it? It replaces. Oh.
You got a 2x.
No, it replaces x though, doesn't it?
Oh, that's right, that's right.
Quadratic formula. We don't do that, Lisa. I don't even know.
Okay, drop something again. Yeah, so on B, if you pick up f of x and replace, let me go back up to my thing. Right here, if you put this in for x right there, yeah, it doesn't really mix with the plus 2, so it's just x squared plus 2x plus 2. Not a lot to talk about on that one. So that would be B, x squared plus 2x plus 2. Determine whether the graph blah 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 has symmetry in the x-axis, the y-axis, and the line y equals symmetry in the axis, the y-axis. The origin. I don't even think we talked about the origin. Symmetry about the origin. Well, I know what the origin is, but we didn't talk about symmetry around the origin.
Is that a question?
Yeah, 5, part 4.
Why don't they just do letters?
Huh?
Why do they change it to like Roman numerals? Like,
Yeah, I don't know.
yeah, those are like,
Yeah.
isn't it like positive, positive, I, positive, negative, I, double negative, triple? What are you saying? It's just part 1, 2, 3, or 4.
were confusing me so bad. Like, what?
I swear.
That's
We had been to school the last 2 days.
I can't remember.
You got another confession.
No.
I'm wondering about the origin thing.
Today's felt so fun.
Today is autumn. Like,
I feel like every Monday is really long, and then every other day is super short. Especially for me, days we have games are shorter than days we have practices.
Oh, yeah. Mine's are till 5:30, so.
Well,
What
yeah,
are we?
practices.
5:30, aka we're finishing up at 5:30, now we're
You're
talking
gonna leave at
to
like 2:30.
The practices take so long. I'm just like,
You have a shorter practice than I do.
why don't
yeah,
you just
I'm not saying our practices are longer, but for me, I'm just like, I
Bartley,
barely.
you should coach the girls.
We gotta leave earlier if we have games.
Okay,
Yeah, we don't
Um,
we still have to show up.
so on 5, I don't think we actually talked much about. We talked more about like part 3 on number 5 than the others, but on part 1, if there's symmetry on the x-axis, that's going to happen if you switch in the. Okay, new page. So let's see, x squared minus xy equals 4. So, what would a graph that has symmetry in the x-axis look like? Maybe something like this, like it's the same from top to bottom. So that happens when you, like if there's a positive y value here, the negative y value also has a point. So on the equation, if we switch y to negative y, does it change the equation? That's how you can tell. So if I switch the y value to a negative y value, do I have the same equation? That would become that would become a plus xy basically instead of minus. So it's not symmetrical.
Wait.
Okay, if I change the y to a negative y value, because these opposite y values should be the same if it's symmetrical. Is it the same? The answer is no. If I change y to a negative y, it becomes a positive plus xy right there instead of a minus xy. It changes the equation, so it doesn't work.
So if it was x squared plus xy, it would be symmetrical. Like on the first equation.
If it was x squared plus x. No, because if it was plus xy and I changed the y value to minus, then this would become it would be a different equation. Okay, here's an example of, like if you had this equation, right? If I change the y value to a negative, it would still be the same equation, basically just y squared equals 4. So that tells me that this one is symmetrical. Usually we do x squared equals 4, like, or, no we don't. We do like y equals x squared minus 4. If x squared equals 4, it would just be x equals plus minus 2. It'd be symmetrical. It doesn't work. Yeah, I don't really care about number 5. So for the y-axis, if it's symmetrical over the y-axis, it should be that we know a lot of these functions. What would be an example of a function that is symmetrical over the y-axis? Like if you flip it,
A parabola.
a parabola, like y equals x squared, right?
Oh yeah, parabola. That's how you say it correctly.
Parabola.
Parabola.
I didn't know how to say it the right way.
Yeah, those are symmetrical. And if you switch the x value on these, it does not change the function. Because all the positive x values have a mirrored negative x value. Anyway, that's how you're supposed to tell. Yes, it matches. The part 3 is the part we actually did on the assignment, which is it symmetrical in the line y equals x? You guys remember doing symmetry over that line? Those are called inverse functions if they're symmetrical. And basically you switch the y and the x value and you ask, does that change the function? So if I switch the y and x value on this, it'd be y squared minus yx equals 4. Does that change the function? Yeah, this doesn't change. That part stays the same. But this part is different. So that wouldn't work either. So all these are no so far. Except for number 4. Symmetrical about the origin. So that would be like, here's a picture of something that's symmetrical about the origin, like that. Okay, that's kind of like the function y equals x cubed.
So would it just be symmetrical over?
It's like things that are over here haven't, like flip kind of thing. It's like flip this way, flip that way. Or here would be flip this way, flip that way. So anyway. And that happens when you switch the x and the y values. And if they're the same, if the function stays the same, then it is going to be symmetrical about the origin. Anyway, so if I change this to negative y squared, or whoops, sorry, it should have been negative x squared. No. Sorry, I forgot what my original function was for a second. It's right here. If I change this to a negative x squared, and I change that to a negative x, and that to a negative y. So you just make everything, all the x values, y values negative. If that gives me this exact same function, then it is symmetrical about the origin. Is it the exact same thing?
Yes.
That simplifies to x squared. A negative times negative is a minus. So yeah, it's the same. So this, whatever the graph of this looks like, I'm not even sure. I'd have to think about it for a while. It's going to be symmetrical about the origin, so number 4 is yes. Don't worry about number 5. We didn't really do that on the homework. So it's no, yes was the answer. Number 6, given the graph of y equals f of x, show the, okay, we definitely did this on the homework. Okay, I'm going to give you guys some graph paper, so we can be kind of neat for these. Okay, this is like something that will pretty much definitely be on the test, something like this. What happens when you multiply the entire to the graph, when you multiply the entire function by 2? This would be 6a.
It gets taller.
Yeah, we call it a vertical stretch. It gets taller. It goes up more and down more from 0. Okay. I'm going to copy the graph that they gave me. So it starts at -3, 2. Let me zoom in. How did I do that last time? Group. I did this. I did that. That'll work. -3, 2. Then where does it go? Down 1 over 1. Then it goes right 1, down 1 over 1, right 1. Down 1 over down 6, right?
That's a div in the graph of y equals f of x.
I'm copying that one they gave me
So
to start with.
I was showing it the right, never mind.
Okay. Alright, so the multiply by 2 is going to make everything twice as big. So where it was at 2, it's going to go up to 4. Where it was at 1, it's going to go up to 2. Where it was at 0, what's 0 times 0? Or times 2? Still 0, so those are going to be the same spots. And over here it's down to -2, so I'll go down to -4. Like that. Which makes everything twice as tall as it was, either going in the positive or negative direction. Maybe I should have drawn. That's what the red line looked like, first line. Alright, do you guys recall what the B value did? Or the B question, the absolute value did? Right, where it was negative, it makes it positive, so all this negative stuff is gonna bounce. Let me go back to my original, I'm gonna cheat here and go back in time. This is the original. So if it's absolute value makes everything positive, so where it was negative, it's gonna bounce to positive. So the first part is going to be the same, and then since it goes negative there, it's going to bounce to positive here. So the green one would be the graph of the absolute value. Alright, for 6c, what if you make the entire function negative? Flips it upside down. So, where it was positive, it'll become negative. Where it was negative, it'll become positive. So, I'm going to do this. Looks like that. Lucy. That sounded like a telegraph. You know what I'm talking about?
Yeah.
They used to use Morse code to communicate over telegraph.
Have you ever used a telegraph?
Heck yeah. I just saw it on TV. Okay, I think I waited long enough.
Is that a telegraph?
Tornado drill.
Wait, is that it? Isn't that tornadoes?
Yeah.
We should go.
When there's blue skies outside and you hear that, that means they're testing it.
That's tornado.
We should run up there.
Hey,
I think we actually do have a tornado drill this week.
Really?
that's not going to be fun.
What?
So we run up the hill. I don't know. I think it's tomorrow though.
We don't get babies
I hope
bitten
it's all
off.
right.
I don't think the babies are coming because they're not.
I don't want to have to go outside.
I think isn't tomorrow supposed to be nice?
Tomorrow? Is that good? Yeah.
Like I saw one day is getting up to 60 this week, but I don't know if it's tomorrow or not.
Yeah, it is.
Okay, number, no, D. Okay, this is probably, D is probably the one that tricks us the most. What happens when they put a +2 directly on the X?
Moves to the left.
Left 2.
Doesn't mean right 2.
Right, it's always backwards.
You guys are so
But you guys remembered it.
I'm so proud
Did
of
you ever
myself.
doubt us?
Yeah.
Well, I would see why you would doubt that side of the room, but this side of the room is
Goddamn.
This was,
Wow. Well, you can have Josiah.
that's
over
a
here.
Remember when Danny remembered the how many feet are like in a mile? What does he want? I don't remember you remembering how
Is
many
that
feet.
even what you remembered?
Yeah.
How many feet are in a mile? 5,200.
boom.
What?
Drop the mic and walk off the stage.
No, it's right.
Why?
Of course he's right.
Is that the only thing you?
Because I learned it in the 3rd grade and I only remember stuff from like 3rd grade or something.
That was your good year. Alright,
That was the
number 7, the graph of a periodic function. What was a periodic function?
It repeats.
Repeats itself. Does the same thing over and over. Is shown at the right. Okay, see that picture there?
It is correct.
What is the period? No, we don't have to graph this. What is the period of the function?
It
How long before it starts repeating itself?
4.
2.
Is it 2?
4. Wait,
Okay.
no.
5.
Oh, wait.
It is 4.
Okay.
Stop trying to trick me.
Yeah. If you look at the very edge of the graph, or if you look at those 2 peaks, that might be easier. It goes from -2 to 2. That's 4. So, yes, A is 4.
Someone wrote 3 on the paper.
7,
Well, you know what?
7's kind of an easy one. That might be good for the test then. What, number B, what are the maximum and min values for G?
4 and 1.
Yeah, 4 and 1 is the max. 4 goes up to 4, that's the maximum, goes down to 1, that's the minimum. Okay, this part confused us the other day. What is the and way back when we were doing trig graphs. What is the amplitude?
1.5.
Okay,
2.
it got from 4 to 1 it's 3 high, right?
Gosh.
But that's not, but the amplitude is like halfway from the middle. So you do half of 3. They put 3 over 2, 1.5 is fine.
Can I put 1 over
No,
1 times 1 over 2?
it'd be 1 over 2/3. If you put that, I'll take it off
Can you
just.
be normal?
What if I wrote
What if you wrote
15.
1.5 and shut up? So you could do
15
that?
over 5?
What if you did that? That'd be really cool.
15 over 5 is right.
Alright, skipping 8. Oh, actually, we skipped one of the assignments too, so we're probably gonna have to skip one of these. Which of the 2 functions, blah blah blah, has an inverse? Oh, we did inverse. Okay, we did number 9. Which one of the 2 functions has an inverse?
That one.
Wait, are we skipping 8?
Oh yeah, he said that.
Remember we
Wait, yeah, you said
we always skip the writing problem because they are more trouble than they're worth, basically. Well, we kind of talked about it on number 5. You can check.
Don't you just switch the X and the Y?
Yeah, you can check by switching the X and Y. I think when we did this assignment, we looked at the graph and if it passed the horizontal line test, you guys remember that?
Yeah.
It has an inverse if it passes the horizontal line test.
This one does.
The 3 plus x squared. Let's see. If I plug in, that looks kind of like number 1, but I don't think it's going to be the same as number 1. If I plug in negative, the domain is all real numbers,
So you're gonna square it, right?
so it's definitely going to be different. switch the x and y and see if it makes a different function or not. So right now it's y equals 3 plus x squared. Square root of that. So if we switch y to the x, is that the same function? Well, how do I solve this for y?
You're going to have to do
Square it.
square.
Yeah, get rid of that. Then I subtract 3, right?
It is the same.
Not quite.
It isn't.
It's y equals x squared minus 3. And yeah, this one's under a square root also, so not even close really. Anyway, no. Oh, they didn't ask yes or no. They just asked.
Doesn't it have an inverse?
It said which has an inverse. Yeah.
Wasn't it last summer?
Yeah.
No, it couldn't have been last summer. It had to be during school.
Last fall. Like September.
Oh wait, I'm doing something wrong.
Oh, we have to find the rule.
Okay.
The second row.
Yeah, yeah. So you guys remember how we found the inverse function?
Yeah, obviously.
Okay. We did what?
He switched
Switch to x and y.
it. What number is this?
And then
It's not.
go ahead and solve for what this is. It's still a, right? Find a rule for the inverse. Oh.
We
Okay.
have like 10 seconds.
Negative g.
Holy cow. So I need to solve for y so I can turn this back into function notation. Anyway. So y is x minus 3. So that means the function, inverse function would be f inverse of x is x minus 3.
Oh, I remember how to go through.
Or I guess, sorry, that was g inverse, but doesn't not that important. So we stopped at 9a, we'll finish it. I might go ahead and make a worksheet so we can start working on that after.